In the last video about cumulative frequency, we discussed how to work out the quartiles and how to interpret cumulative frequency graphs. So that was great when we had one single situation. What we're going to do now is actually compare two different distributions using cumulative frequency. So it could be that you have two rival companies, or you could have, I don't know, two companies and you're maybe a market researcher, and you've got data for both of them. You make cumulative frequency graphs for both of them for some situation, like maybe length of time. Maybe maybe we're looking at call center times. So you look at maybe internet companies like TalkTalk, BT, Virgin, and you look at you want to work out the average time of a phone call to the support team to evaluate how effective they are, or maybe how many calls are made made by the customers. You would use this sort of analysis that we're going to do today to do that. So this is really useful again. So for a starter, I want us to finish the cumulative frequency table that I've got here. I want you to then plot a cumulative frequency graph, as we've done many times before now. I want us to find the median age from the graph and use the graph to find an estimate for the number of the teachers surveyed who are more than 56 years old. So pause the video, have a go, and when you're done, press play. I went straight up, I scored up, and then I scored across, and I read off cumulative frequency there of 91. So that means that 91 of the teachers are going to be less than 56 down here somewhere. And then that means that because there are 100 teachers surveyed, that means that there must be 9 to the right of that. So we have 9 teachers who are older than 56 years old. Well, that's an estimate. It's a good estimate. I mean, cumulative frequency graphs are fairly good estimates, but it is just an estimate still. That's often the case with statistics. You have to work with estimates. So we're going to do a bit of data comparison. That's what today's learning objective is, to be able to compare two distributions using their medians and interquartile range and to make relevant conclusions from that. So we have two cumulative frequency graphs this time. So 140 girls, so it might be a bit small, but you can probably see it on your sheet. So 140 girls were asked how long they spent revising for their GCSE exams, and the cumulative frequency diagram shows the results. So we have cumulative frequency on the y-axis as normal, time in hours on the x-axis, and you've obviously got your cumulative frequency graph. And then we have a very similar graph for the boys. So that is shown in part B. Now, Trevor makes two statements. The first statement is that the boys' interquartile range is greater than the girls', and that on average, boys spent more time revising. Now, we need to use the two cumulative frequency graphs to evaluate the truthfulness of Trevor's statements. So, are they both correct? Show calculations and give reasons for marks. So, obviously, work-ins are going to be very important here. So, statement number one, we want to work out the interquartile range. And obviously, we're comparing the boys and the girls, so we need to work out the IQR for both of the graphs. So let's do it for the girls first. So we can see there were 140 girls surveyed, so we need to go to, so 140 over 2 is obviously 70, so we need to go across from 70 and then go down. So that is obviously going to be 52. So yeah, it's got up in ones, that's 52. So 52 hours, that looks like 5.2, sorry, 52. 5.2 hours wouldn't get you particularly good marks. So that's the median. To get the, I don't know why I worked out the median, I actually want the interquartile range, but anyway, that's good to know. So to find the lower quartile, we need to go up a quarter of the way up the distribution. So the lower quartile, we just do the total frequency over 4. 140 girls were surveyed, which is 140 over 4, which is 70 over 2, which is 35. So the position of the lower quartile is 35. It's the 35th term, 35th girl surveyed. So I've got 20, 30, 35 is going to be halfway, so it's there. Again, you want to be as neat as you can. There we go. So that's exactly halfway there. So that is, so if I read that off, it's gone up in ones, isn't it? So 31, 32, about 32 and a half. So about 32 and a half hours. Upper quartile, I need to go up 3/4 of the way. So 3/4 of n, 3/4 of the total frequency, 3/4 of 140. So 1/4 of 140 is 35, so that makes 3/4 105. 35 times 3, 105. So we need to go up to 105 on cumulative frequency, which is, now if we look at the way this one is distributed, so so we can see 105, 100's here. We are going up in fives. We're going up in twos, 2, 4, 6, 8, 10. We're going up in twos. So 105 is going to be 2, 4, 2, 4, 6 is there. So it's going to be halfway. So it is there. And we go down. So my upper quartile is there. So the upper quartile is, so 50, 55, 56, 57, 58, 58 and a half roughly. Okay, so we want to work out the IQR. The interquartile range is going to be the upper quartile minus the lower quartile, which is 58.5 minus 32.5. So the 0.5s cancel, we just get 26. So the IQR interquartile range is 26 for the girls, so 26 hours is the interquartile range. Now, it's useful to work out the interquartile range when there are two distributions, because depending on which one is larger or smaller, you can make conclusions about the spread of the data. So we're going to do the same thing for the boys' cumulative frequency graph. There's 140 measured again, so we just go across. To work out the interquartile range, we do 140 over 4 for the lower quartile, which is 35, as before. So we go up to 35, so that is here. So there we go, we go across. Then we go down. And I'm going to do the same thing, but 3/4. So 3/4 was 105. So 2, 4, 5 is here. Right, so now I can work out the lower quartile and upper quartile. So lower quartile seems to be 15, 16, 17, 18, 18.5 hours, and the upper quartile is 41, not 41, sorry, 46 hours. So the IQR is upper quartile, take away lower quartile. That's going to be 46, take away 18.5. Which is going to be, what's that going to be, 27.5 hours. So let me zoom out. So now we can compare the two. So for the girls, let me just, the boys interquartile range is, so the boys interquartile range is 27.5 hours. The girls is, let's see, 26. So that means Trevor is correct. So Trevor is correct here, because obviously, oh no, yeah, no, he is correct, because obviously the girl's 26, yeah, he's right. So Trevor is correct for this statement at least. And in order to get the marks there, you would have to show these workings. You would have to show the upper quartile and lower quartile for each and how you calculated the interquartile range. So for this statement. Okay, statement number 2. On average, the boys spent more time revising. So in order to compare that, you need to look at that word on average. When you see on average and you're looking at cumulative frequency, you should be thinking of the median, because the median is the only average that we can get from these graphs. I can't work out the mean or the mode from these graphs. I can only work out the median, or an estimate for the median. So we need to find the median for both. So we found it for the girls, and it was 52. So we need to work it out for the boys. So that means we need to go halfway. So half of 140 is 70. So we need to go up to 70 on our graph for the boys. And we need to go across. So I'm going to have to, let me change colors so it's a bit easier to see. So we're going to have to go across from 70. And then it's very convenient. There is a point there, which is nice. That's easy. We go down. So even though it's obvious, we still draw the lines on the graph because that counts as work-ins. So we get to 40 hours being the median. So for the boys, it is only 40. So let's go to 100. So Trevor says, on average, the boys spent more time revising. Well, he's dead wrong because the girls have a median time of 52. So let me say no. The girls had a median time, you have to mention the word median here to indicate that you're using the median as the average here. So no, the girls had a median time median time revising or studying of 52, so we can see that here, 52 hours. The boys, so maybe a semicolon will work there, the boys' time was only 40 hours. So we can say he is incorrect here. So some conclusion is fine there. Good. So that would get you the 4 marks as long as you show all your work-ins and you're clear on what statistics you're getting from the graph and how, or both the graphs. So then D, I've added in a little bit of this question. So it's a GCSE question, higher tier paper or intermediate paper, and I'm giving you an extra part. I'm saying what can we conclude about the spread of the two distributions? So where you see that word spread or where you see the word consistency or variety, you should be thinking of the IQR whenever you have cumulative frequency. So basically, we can see that the distribution with the highest IQR is the boys. So I can say that the boys have a higher interquartile range. So their results are more spread out. Their results are more varied. Or not their results, sorry, their times, I should say, because we're not looking at exam results, we're looking at times revising. So their times are more varied. So their revision times were more varied than that of the girls. So we're going to have a look at another example. This is very typical of a GCSE question now. I mean, the last one was a GCSE question. This one is one I've made. It's very similar to a GCSE question. Then you've got a question to try. Then we have a GCSE question to do. And then basically, if you've understood everything in these 3 videos, you should be really good at cumulative frequency. So let's do this question together before you get on with an example on your own. So this question, we're given 2 cumulative frequency graphs again, so that's a nice hint that we have to compare distributions. So we have 2 schools, we have Coleg am Grist, and we're given the times, we're given a cumulative frequency graph showing the times that pupils revise for their step 1 exam. So step 1 is a maths exam you do when you're 18 if you want to go to like a really, really top university for maths. And then the cumulative frequency graph on the right is for Ysgol Gymraeg Hawlfa and how long their pupils studied for step 1 exam. So if we look at the first one, it goes up to 60. So we have 60 pupils surveyed, and in the right, it goes up to 70 pupils were surveyed. So for part A, we want which school had pupils who, on average, studied for a longer time, and you must give evidence using relevant statistics from the graphs. So 3 marks, obviously workings again are important here, and how you draw on the graphs. So we can see there's that word on average. So that means we want to look at the medians. We want to compare the medians of the two distributions. Sorry. So for the first one, we know that 60 pupils were surveyed. So 60 over 2. So just to be concrete, let's write that down. So the position of the median is going to be 60 over 2, which is 30. So the 30th value is going to be the median. So we go across from 30, and then we go down. So we get to 40. So that means that the median time spent revising in Coleg am Grist is 50, not 50, 40, sorry. So I'll just write that here actually, and then we'll write it down more neatly there. And then for the second one, Asfog Gymraeg Hawl Dda, we can see that 70 pupils were surveyed, so we need to find the position of the median. That is going to be 70 over 2 halfway, which is 35. So let's go across, so 30 and then 35 is there. So let's go down from there. There we go. And let's read across. So we can see that we're going up in 2s again. So 42, 4, 6, 8, 49. So 49. So we can see that the median for the first school is 40. Median for the second school is 49. So to get those 3 marks, I would say median for Coleg am Grist. So I'll just put CA. I won't put that actually. I'll put Coleg am Grist. So the median for the first school is 40 hours. Median for Ysgol Gymraeg Hawl Dda equals 49 hours. So Ysgol Gymraeg Hawl Dda had pupils on average. So on Ysgol Gymraeg Hawl Dda, on average, had pupils who studied for longer. Again, only on average because this is an estimate. Who studied? My writing is really shocking here. My apologies, everyone. I need to get a new graphics tablet, I think. Of course, bad work always blames his tools, but there we are. So B, which school had pupils with more varied study times? And again, I should say they're on average. You must give evidence using relevant statistics from your graphs. So this time, when we're looking at variety or spread or consistency, we need to use the interquartile range. Or, the range would also work, but when you have a cumulative frequency graph, you want to use the interquartile range. So for that, we need the upper quartile and lower quartile of both distributions. So first of all, let's look at Coleg am Grist. So there were 60 pupils measured. A quarter of the way up the distribution is going to be 60 over 4, which is 15. So the 15th value is your lower quartile. Upper quartile is going to be, well, if 60 over 4 is 15, we want 3/4 of 60. That will give us the position of the upper quartile. So that's just going to be 45. You can just do 60 over 4 is 15 times that by 3, we get 45. So that means we go up to 45, we score across. So there, I can barely see that. So up to 45, and then we go down there. We're going up in twos. We got 72, 73. So I get 73 hours there for my upper quartile. And the lower quartile is 15, obviously. So 15 is going to be there. And then we go down there. So that gives us 22, 24, 25. 25. So the IQR, interquartile range, is going to be 73 take away 25. So let's work that out. So we get 48. And then cumulative frequency for Ysgol Gymraeg Hywel Dda. So we have 70 pupils measured, or surveyed, sorry. So we're going to do, for the lower quartile, the position is going to be 70 over 4, which is just 35 over 2, which is about 17, not 17.5, that is going to be about 16.5. 17.5 was actually correct. That's the position of the upper quartile. So we go up to 17.5. No, that's the position of the lower quartile, my apologies. So we go up to 17.5, which is going to be, so 10, 12, 14, 16, 17. No, am I doing this? Sorry. I've forgotten to count, sorry. 10, 12, 14, 16, 18. So 17 is there. 17.5 is not very easy to draw. It's going to be about there. It's about as neat as I can do. Takes us there. There's a little bit of tolerance in these questions, but that gives us about 32, 34. I would say that's about 35. And then for the upper quartile, we need to do 3/4 of 70. So 210, 50 something. So yeah, 52.5. So the 52.5th value is going to be the position of the upper quartile. So 52, 54, 53, it's about there. It's a bit tricky with this scale. And there I get roughly 64, so about 64 hours for the upper quartile. So to work out the interquartile range, we do 64 upper quartile, take away 35 lower quartile, which obviously gives us 19. Well, that doesn't give us 19, it gives us 29, sorry. And that's our interquartile range there. So for B, which school had more varied study times? So what I would say is we need to work out the IQR for both, which is what we've done. So make sure you put your workings in the correct area with the lines, but for me, because of space, I've had to put them on the graph. So IQR for Coleg am Grist, Coleg am Grist, we have got 48. Yeah, 70, yeah. And then for IQR for the second school, so for Ysgol Gymraeg Hywel Dda, we have 64 minus 35, which is 29. So we can see that the first school, so Coleg am Grist has the higher IQR. Therefore, it has it has more varied. Well, so I could say it has more varied or spread out results. Results of the survey. Okay, so basically for the 3 marks in both cases, you've got to work out the upper quartile, lower quartile. Or for the first one, you have to work out both the medians and then say which one has the higher median. Higher median means higher average. For B, you've got to work out the IQRs, and then the higher IQR means more spread out data. So that is all there is to it. And if you can do that, you'll be fine with basically any question on it. So with that in mind, I've got a question I'd like you to try. So this time we have two games companies, so Wada Company and Carl Game Company, and we've got support teams, and the cumulative frequency graph shows the times, or it shows the length of phone calls to the support teams for each of the companies. So for A, I want which company on average had longer phone calls, so longer phone calls to the support teams. And again, you've got to use statistics on the graph to justify your answer. And then which company had a greater variety in the length of phone calls, the support teams. And again, you've got to use statistics to justify your answer. So have a go. Very similar to the last question. When you're ready to go through the answers, press play. So here are the answers. So just like before, I've worked out the median, upper quartile, lower quartile of both of the cumulative frequency graphs. I've then worked out the interquartile range for each of them, and I've used those, what we would call summary statistics, to answer the questions. So for A, we want which company on average had longer phone calls. So that means we want to see which one of them has the higher median, because when we see that word average applied to cumulative frequency, we should think median. So for I should say Quartile, actually. Quartile is a dialect thing. So Quartile Cymru has a median of 100 minutes, and then Canolfan Gamai Cymru has a median of 150 minutes in terms of length of phone calls to the support teams. So, this could be something to do with how difficult their software is to use or something like that. These guys could be licensing out game engines or whatever. So we can see that the CGC one, the Canolfan Gamer Company, has the higher median time. So that means on average their length of calls was longer. And then for the variety, when you see variety or spread or anything like that to do with consistency, you should be thinking of the interquartile range. So the interquartile range for Chwarae Cymru was 85 minutes, and for Canolfan Gamer Company was 150 minutes. Now, the Canolfan Gamer Company has the higher IQR, so it means that it has the greater variety in the length of phone calls. So you'd need to have, for the 3 marks for each of them, you'd be expected to have both the medians correct, and then you'd have to have a conclusion based on that. So higher median, so on average length of calls was longer, that would be a valid conclusion. Higher IQR for CGC, that means there's a greater variety in length of phone calls. So I should say maybe all phone calls to guarantee it. If you do that, there's no reason why you won't get the 3 marks for each. Okay, so the last thing I want to do is go through a GCSE question, which is a little bit tricky because it's a bit non-standard, but I'm sure you guys can manage it. So let's get rid of this. So if you want to try this on your own, that is brilliant. Just pause the video, have a go at it, and then press play when you want to go through it. Otherwise, I'll just go through it with you. So an exercise was carried out to time a group of 100 passengers leaving an aeroplane using the emergency exit. The results are illustrated in the cumulative frequency diagram shown below. So for question A, we're asked how many passengers took between 20 seconds and 35 seconds to leave the plane. Well, a cumulative frequency graph tells us how many more people than a certain amount or how many fewer people than a certain amount. So we need to look at the difference here. So I can see how many people took less than 35 seconds. I can read that off the graph. All I've got to do is go across to 35. So this graph is nicely going up in 1, so I can just go 3, 4, 5. So if I go up to 35, so 35 seconds, it's actually exactly there. And I read off. What that tells me is that, so 80, that's going to be 90. So what that tells me is that 90 people took less than 35 seconds to leave the plane. So I can say 90 took less than 35 seconds to leave the plane. Easy. Now, if I work out the number of people in between, we just need to work out the difference. So 90 take away 30 is just going to be 60 people, 60 passengers. How many passengers took more than 40 seconds to leave the plane? Well, to do that, we can score up at 40. So there. So there we go. So we can see that the graph is going up in, it's going up this time, it's going up in twos this time. So that's going to be 90, 92, 94, 95 I get. So how many passengers took more than 40 seconds to leave the plane? Well, 95 passengers took less than 40 seconds. There's 95 passengers back here. There's 100 passengers measured. So we just need to look at the difference. 100 take away 95. There's going to be 5 passengers to the right of here. So it's 5 passengers took more than 40 seconds to leave. And then part C is the sort of non-standard part. So I'll do that up here. So the regulations state that 85% of the passengers should be able to leave the plane in less than 30 seconds. We want to complete the following statement showing our working. So in this exercise, the target time for passengers leaving the plane in an emergency was missed by so and so many seconds. So what we need to do is work out, so if we do, we need to work out what time 85% of the passengers were able to leave in a time more quickly than that, so in a time lower than that or less than that. So we can see that there are 100 passengers. So if we go to 85% of that, that's just going to be 85 on the cumulative frequency. So if we go to 85, so it's going up in twos, 2, 4, 5 is there. So in fact, I'm going to have to worry about some of my writing on the graph. So 82, 4, 5 is there. And I can go down. There. Okay, so so we can see two, so it's going up in 1, 31, 32, so I get about 33. So basically what I have is that 33 seconds. So what I can say is that 85%, because 85% of 100 is just 85, so I can say 85% of passengers certainly left in a time less than 33 seconds, which is here. So 85% of passengers left in less than 30 seconds. Not 30 seconds, in less than 33 seconds. But what they want is for the 85% of passengers to be able to leave in less than 30 seconds. So we can see the target time was missed by 3 seconds. And in the mark scheme, they will accept any answer between 2 and 3 seconds. So there's a little bit of leeway, but not too much. So that basically concludes what I wanted to go through. So if we go back to the learning objectives, we compared two distributions using the median's interquartile range, and we made some relevant conclusions from cumulative frequency data. So that was like, is the safety regulation being met for this question? We looked at two different game companies and how long the phone calls were to each of the support teams, which gives us some indication of how good the support teams are, or maybe the difficulties with the software that these companies are producing, and various other questions. So all of these are GCSE higher style questions. They're like GCSE higher questions. So if you can do these, you're well on your way to understanding this topic for GCSE. If you have any further queries, just let me know on Teams. So I'd like you to do the My Maths questions I have set on this, as well as the MathsWatch questions. Again, any problems, just let me know. I'll be happy to help.